So let's start with section 7.5. Multiple angles on product to the sum formulas. So also when you solve the examples, we're gonna go back to the same circle. So the first formulas is the multiple angle formulas. Let's check the multiple angles formula and be careful, these are the angles. Two, that's why it's double angle formulas. And here's the angle is going to be sine 2 sine u cosine u. And when you have cosine 2u, it's going to be cosine squared 2u and sine squared to the u minus sine squared. So with the cosine, we have three formulas. You can use the first one, the second one, or the third one, which is 2 cosine squared to the u minus 1, or 1 minus 2 sine squared to the u. Or you can tangent 2u is going to be 2 tangent u and 1 minus tangent squared to the u. So here's the first part of the section. Now we're gonna solve 2 cosine x plus sine x plus sine 2x equals 0. So if you look to the first part here, we don't have to use any formula. It's 2 cosine x. So just write down 2 cosine, here's the x, plus. If you look to the second one, we have sine 2x. Sine, which is double angle. So I can use the double angle formula. So it's going to be sine 2 sine u, that means sine, and x cosine, and here is x equals 0. So I'm using the double angle formula here for the second part. Now, if you look, here's the first term, and here's the second term. So the common between these two terms is the cosine. So if I took the cosine x out, what's the left from here? It's 2 and a plus. If you took 2 cosine, because also we have a common, the 2. So the left here is going to be 1 plus, and here is going to be sine x equals 0. Now by using the product zero factor probability, so maybe 2 cosine x equals 0, or 1 plus sine x equals 0. That's mean in this case, divide both sides by 2, so that's mean cosine x is going to be 0. On this side is going to be sine x equals 1. In this case, we need to go back to the circle to locate the angles, which is going to be pi over 2 and 3 pi over 2. That's means if you go back to the circle, x is going to be pi over 2, and x is going to be equal to 3 pi over 2. But we don't have a circle. That's mean we have to add 2 and pi plus 2 and pi. We have more than one solution. They didn't ask you to find a solution in one circle, so you have to add how many circles? 2 and pi, which is 36 plus times 2. 2 pi, 2 and pi. This is the first example. Now we go to the second part of this section, which is power reducing formula. Again, we have the three formulas for power reducing formula. The first one is going to be sine squared to the u. It's going to be 1 minus 2, 1 minus cosine 2u over 2. And cosine squared to the u is going to be 1 plus cosine 2u over 2. Tangent squared to the u is going to be 1 minus cosine 2u and 1 plus cosine 2. So here is another three formulas. If you check the next example, we have sine to the power 4 to the x, and they're telling you use the power of the cosine. of multiple angles. So we're gonna use the power of cosine, but I have sine to the power 4. And we already know sine to the power 4 is going to be that I'm doing x to the power 4. I can write down as x squared times x squared. It's the same thing, the same base, add the exponents will be x to the power 4. So the same thing with the cosine, I can say with the sine. Sine to the power 4 to the x, I can say it's sine squared to the x times sine squared to the x. So we can do the same thing here. Or you can say it's sine squared to the x and everything squared. Both ways going to be right. So let's use the same techniques on this example. So sine to the power 4 to the x, I'm going to say it's sine squared times sine squared. So sine to the power 4 to the x, it's equal to sine squared to the x times sine squared to the x. Then I need to apply the formula for each one. The formula for the sine squared is 1 minus cosine 2u. That means on this part, this one going to be equal. I can say it's 1 minus cosine x is going to be 2x divided by 2. The same thing here times, I can say sine squared to the x is going to be 1 minus cosine 2x divided by 2. I'm just using the formula. Then what I'm going to do next step. Next step, you're multiplying two fractions. So when you're multiplying two fractions, like for example, 1 over 2 times 3 over 5, you're going to multiply 1 times 3 and 2 times 5. So the same thing here, I'm going to multiply this one times this one and 2 times 2. 2 times 2 is 4, so I'm going to take 1 over 4 out. And the left is going to be multiplying 1 minus cosine 2x times 1 minus cosine 2x. How are we going to multiply? Two binomials in a FOIL. So 1 times 1, so I'm going to 1 over 4, open the parentheses, 1 times 1 is going to be 1. 1 times minus 2 cosine 2x. And again, minus cosine 2x. Cosine times cosine will be plus cosine squared to 2x. Next step, we're going to combine the lactams. Combine the lactams, so 1 over 4, and here's going to be 1 minus 2 cosine 2x, and it's going to be plus, because this term exactly the same thing here. We're just going to combine these together. Plus cosine squared to the 2x. Now, what's the next step if you go to this one? We need to simplify it more. This is the right solution. But yes, I can simplify it because this is cosine squared to the 2x. That means we can use the power rule again on this part. To use the power rule here on the cosine is the opposite of the sine. It's 1 plus cosine. And also you have to double the angle. So instead of 2x is going to be that mean only on this part, what I'm going to plug in here. I'm going to plug in here the formula cosine squared to the 2x, which is the power formula for the cosine, which is going to be equal 1 plus cosine 2 times 2 to the angle, so it will be 4x, and divide by 2. I'm going to plug in this one instead of this part. Let's see what we get. So after we plug in cosine squared to the 2x here using the same formula, now we have 1 minus cosine, so 1 plus to the cosine. So 1 plus cosine 4x. Now I need to simplify it. Look, I have I have a fraction here. You can write down this over one, you can write down this over one, or you can to simplify it, if you multiply the whole thing by 2/2. Because I can say this is over one, this is over one. Now, this two, because I have to multiply by one, and I can compare the one 2/2. 2 divided by 2 is 1. 2 times 4 is going to be 1/8. So here is going to be 1/8. And 2 times 1 is going to be 2 minus. 2 times 2 is going to be 4 cosine 2x plus, when you multiply 2 times here, you're gonna cancel the 2 with the 2, so the left is 1 plus cosine 4x. Let's check this again. I'm multiplying the top part because it's a fraction, fraction. Multiply 2 by the whole part here at the top. And 2, I'm gonna multiply it with the 4, like keep outside this 2, multiplied by 4 is going to be 8. Then distribute the other 2 by the whole thing. That's what we're in. Now, next step, we're just gonna combine the last terms, which is 2 and 1. So it's going to be 1/8. 3 minus 4 cosine 2x plus cosine 4x. And again, you can't combine these together because they are different angles. 2x and 4x. That's it for the system. The third part of this section is the half angle formulas. Here we have 3 formulas for the sine, the cosine, and the tangent. Let's check these formulas. It's half angle formula. So you have to be careful. Like sine, half the angle, which is u divided by 2. It's going to be plus or minus 1 minus cosine u divided by 2. The same thing for cosine divided by 2, that's mean half of the angle u, which is plus or minus 1 plus cosine u divided by 2. And for the tangent, we have 2 parts for the tangent. Tangent u divided by 2, you can use this part by saying 1 minus cosine u divided by sine u, or you can use this part. Sine u, 1 plus over 1 plus cosine u. So one of these parts you have to use. You can't use both on the same time. Be careful. But the sine of the u, because we have a plus or minus here, we have a plus or minus here. How are we going to use that? It depends about the location of sine and location of the angle u, which is u/2. So that means if it's in the first coordinate, it's going to be positive. If it's in the second coordinate, which one is going to be sine or cosine? The sine, that's mean positive. If it's cosine, it will be negative. So it depends about the location of the angle. Like if you go back to the circle, if it's here, all is going to be positive, sine, cosine, tangent. If it's here, only the sine is going to be positive. If it's here, only the tangent is being positive. And if it's here, only the cosine is going to be positive. So it depends about the location of the angle. We can consider which one is going to be the sine, positive or negative. Let's check this easy example. But how are we going to use? It's first of all, it's in degree mode. We need to find sine 1/5. So how are we going to check that? Sine of 1/5. I know it's on the second coordinate. 1/5, it's on the second coordinate. That's mean here to find the sine for the second coordinate is going to be positive. That means our result is going to be positive. 1/5, it's u divided by 2. So it's came from 210 divided by 2, we're going to get 1/5. So here, to find the value of sine 1/5, it's equal sine 210 divided by 2. That's mean the angle is u equal to 10. Here's the 2. Sine u divided by 2. This is the u, 210 divided by 2. So in this case, it's going to be equal. I'm going to use this form. And it's positive. It's positive because it's in the second coordinate. It's going to be 1 minus cosine mu, so cosine 210 and divide by 2. Because we're only 1 minus cosine 2. Now, the cosine 210 is going to be, it's the same thing, negative cosine theory. Or if you check to the end, if you go back to the circle and you check cosine 210 is going to be square root of 2, square root of 3 divided by 2. So in this case, this one is going to be square root of 1 minus square root of 3 divided by 2 over 2. Or you can say, so 210 on the third coordinate. So the sign for the 210 is going to be negative. That's mean it's negative square root of 3 divided by 2. In this case, negative times negative is going to be positive. So it's going to be square root of 1 plus square root of 3 divided by 2, and everything divided by 2. Now we're going to find the common denominator here on the top. So it's going to be square root by, how are we going to find the common denominator? By multiplying, because this is over 1, and you're going to multiply by 2, multiply here by 2. So it's going to be 2 plus square root of 3 divided by 2, and everything divided by 2. And careful, the whole thing here under the root. In this case, it's going to be square root of 2 plus square root of 3 over 2 times the whole thing is going to be 1 over 2. 2 times 2 is going to be 4. That means going to be square root of 2 plus square root of 3 divided by 4. Take the 4 outside the root, so it's going to be square root of 2 plus square root of 3 and everything divided by 2, which is positive because we're looking for the sine 105, which is on the second coordinate. That's it. What's it? So let's go to the fourth part, which is another part of the formulas, which is product to sum formula. How are we going to convert the product to sum formulas? So the same thing, if you have a product between sine, sine, you can use this formula. If you have cosine, cosine, you can use this formula. If you have sine, cosine, you can use this formula. If you have cosine, sine, you can use this formula. So you have to be careful which one you're going to use. It depends about the example. And here's an example. Rewrite the product cosine 5x, sine 4x to the sum of difference. That's mean I'm going to use this formula. Write down the product to sum or difference between 2 sine and cosine. So let's check which one we're going to use. Cosine 5x. So this one is going to be the u. This one is going to be the u, and this one is the u, and this one is the v. And we have cosine, sine. That's over here, put in space. So we need to find cosine 5x and sine 4x. To use the formula, which formula we're going to use? Cosine, sine, cosine, cosine, sine. That's mean I'm going to use this one. It's going to be half, open bracket, sine, addition of the two angles. So sine, the addition of 5x plus 4x, minus sine Now, u minus v. So it will be 5x minus 4x. That is going to be half sine 9x minus sine. That's it. You convert the product, which is between cosine and sine, to difference between sine and sine. That's it. That's the only thing we want to do. That because they tell you just rewrite the product as a sum of difference. We rewrite the product as a difference between two angles. That's it for the signal. So one more part for the other section is going to be sum to product formula. Here's another formula. If you have sum between sine and sine, you can use this formula to convert sum difference to a product between sine and cosine. You can use these formulas. And if you look now, we have examples. The first example, they're just going to ask you find sine 2u. So it's going to be sine 2u, use the double angle. So it's going to be 2 sine cosine. So it'll be 2 sine cosine u. That's mean here is going to be 2 sine u cosine u. That's it for the first example. Now with the second one, we need to check which formula is similar to this one. Which formula is similar to this one? 1 minus cosine 2u and 1 plus cosine 2u. This formula is exactly similar to tangent square to the u. Tangent square to the u is the same formula here. Now the next one, they ask you to write down the formula for find sine u over 2, which is half angle formula. So it's going to be square root of, don't forget the plus or minus because you don't know the location of the angle, u over 2. And it's going to be 1 minus cosine u divided by 2. That's it. That's the only thing we're going to do with the first 3 examples. Now let's go to the next example. Next example, they ask you solve the equations, find all the solutions in the interval. So they tell you to find all the solutions here, so be careful. Let's see, we need to find the solutions only in one circle. So you have to go back to this circle. So now let's look to this example, how we're gonna solve it. First of all, sine to the x, I can't do anything with this one. But if you look to the sine 2x is the double of the angle. That's mean, yes, I can use double angle formula. Sine 2x is going to be 2 sine x cosine x. And here's the minus sine to the x equals 0. So I'm using the double angle formula on this part. And here is the minus, write down the minus, and write down sine, exactly the same. So that's what I did. Okay, now if I look, I have this term, because it's multiplication, so it's considered one term, and here's the second term. Now, what are we gonna do next step? I have common between these two terms. Let's factor out the common, which is sine to the x. That's the only common. What's the left? From this part, if I factor out the sine, the left is 2 cosine x. Here's the minus. If I factor out the sine, the left is 1. Anything with this. Okay, that's good. By using zero factor property, I can say sine equals 0. So sine x is going to be equal to 0, or 2 cosine x minus 1 equals 0. This one is already solved. I just need to go back to the circle and find how much the value of x. Here we're gonna add 1 to the both sides. Cancel here, so 2 cosine x equals 1. Then divide by 2. That's mean cosine x is going to be equal. Now we need to find the value of x. And they're telling you in one circle. So you don't have to add the 2 and 5. That's mean which angle give me sine x equals 0 is going to be 0 and 5. If you go back to the angle, that's mean. And which angle is going to give you cosine equal half? If you go back to the angle, the result is going to be 0, pi, and pi over 3, and 5 pi over 3. 5 pi over 3. If you go to the circle, so the solution is going to be 0 pi, pi over 3, and 5 pi over 3. That's it for this example. Now let's go to the next example, and we're going to do exactly the same thing. Next example, we need to solve the equations, find all the solutions with this interval. So here's the interval between 0 and 2 pi. That's mean also we need to find the solutions for one circle. So we don't have to add the 2 and pi. Now, if you look at the formula, we're going to do exactly the same thing. I have cosine 2 pi. That's mean I'm going to use the double angle formula on the first part and leave the second part exactly the same. But if you go back to the formulas, we have 3 formulas. We have cosine square minus u minus. Which formula you're going to choose? We have 3 formulas for the cosine 2x. Okay, you're going to think. I can't use the third one, and I can't use the first one because there's sine in it. So in this case, if I use the second one, which is 2 cosine square minus 1, I'm going to convert everything here to the same angle. So in this case, the second formula is going to be helpful to use on this example. So the first part here is going to be 2 cosine squared to the x minus 1. This is the formula for cosine 2x. And I'm going to write down minus cosine x equals 0. Again, I'm using the formula cosine 2x equal 2 cosine squared to the x minus 1. I'm using this formula for the double angle. Now, what's the next step? How are we going to solve this one? Think about that. This is term, second term, third term. There's minus here and there's minus here. I can rearrange this one again. So I can say it's 2 cosine squared to the x. I'm going to say minus cosine to the x and minus 1 equals 0. I'm just going to flip these 2 terms. Now, if you look to this one, this looks like 2x squared minus x minus 1, just like a monomial. So I can solve it by factor. Now we're going to factor this one. So I'll put 2 parentheses, we'll put the 0. And I have 2 cosine, so 2 cosine x here and cosine x here. 2 cosine times cosine, 2 cosine squared. And then we have minus 1, so we're going to put plus 1 here, minus 1 here. And let's check. We need to check is that right? Let's check that. If you multiply 1 times cosine, it's going to be cosine x. If you multiply these, it's going to be negative 2 cosine x. And add these together, it's going to be negative cosine x. So this one is going to be right. That's me, I'm choosing the right options. Let's go back here. That's mean 2 parentheses equals 0 by using 0 factor property. It's going to be 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. Solve this one, you're going to minus 1 and you're going to divide by 2. So that's mean cosine x is going to be equal to negative 1 over 2. And here, just move the one to the other side. Let's move the side next. Now we need to check on the circle which angle give us cosine x equal negative half, and which angles give us cosine x equal 1, which is 0, 2 pi over 3, and 4 pi over 3. That means the solution is going to be 0, 2 pi over 3, and 4 pi over 3. These angles give us cosine equal negative half and cosine equal 1. The 0 gives you cosine equal 1, and negative half is the angle 2 pi over 3 and 4 pi over 3. That's it for this example. Go back to the next example. 6. We're going to solve this one. I have to be careful with this one. Solve on the interval 0, 2 pi. And this one, because I need more space for this example. The best thing to solve this one, you have two ways to solve it. You can convert the sine, the tangent and the cotangent to a sine and cosine, and you're going to work on it, or you're going to keep it as a tangent and cotangent. It's up to you. Both, it should be right. Let's keep it as a tangent and cotangent, and you can try to use the sine and cosine. But I need to keep it as a tangent and cotangent and think about a way to solve this one. First of all, I have two tangent 2x here, which is using the formula of double angle. So this part here is going to be 4 tangent to the x over 1 minus tangent squared to the x. 1 minus tangent squared to the x. Minus 2 cotangent. I don't have formula for the cotangent x. We'll see. Next step, I'm going to move the cotangent to the other side. So it's going to be 4 tangent to the x divided by 1 minus tangent squared to the x equal 2 cotangent to the x. Now what do we do next step? Next step, let's think about that. If I consider this is over 1, I can do the cross product. This one times this one. So by doing the cross product to get off of the fraction, you can multiply the whole thing here by 1 minus tangent squared to the x, these two parts, or you can just do the cross multiplication. Both is going to be the same result. But we need to convert the fraction just to equations. It's easier to work on. So that's mean 4 tangent x times 1 is going to be 4 tangent x times 1 equal 2 cotangent to the x times 1 minus tangent squared to the x. See what we're going to do next step. Next step, I'm not going to do anything here. I'm going to just distribute this side here. That's mean is going to be 4 tangent to the x. Oh, 4 tangent to the x equal 2 cotangent x times 1 is going to be 2 cotangent x minus 2 cotangent times tangent is going to be 2 cotangent x tangent x squared to the x. That's good for us. Now, next step. We already know the cotangent is here, the cotangent is 1 over tangent, which is the reciprocal of tangent. So I'm going to convert the cotangent to 1 over tangent to simplify this part and keep the rest exactly the same. So 4 tangent to the x equal. Here's 2 cotangent x minus, here's 2, the cotangent is 1 over tangent to the x, and here's tangent squared to the x. Tangent squared, the operation is multiplication. I can cancel one of the tangent with this one. Let's see what's there left. The left from here is 4, 2 tangent, 2 cotangent, that's me, 4 tangent x is going to be equal. The left here is 2 cotangent x minus 2 tangent x. That's good. Let's move these two terms to this side. If I move these two terms to this side, it's going to be 4 tangent x and minus 2 cotangent x and plus 2 tangent x. The everything will go to the zero. Now, yes, I have like terms. I can add these two terms. So it's going to be 6 tangent x minus 2 cotangent x. Oops. Cotangent is 1 over tangent. So I have 6 tangent to the x minus 2 over tangent x. Equals 0. Because cotangent is 1 over tangent. 2 times 1 is going to be 2, and here's the tangent. Now we need to combine these two fractions. So what we're going to do, let's say this is over 1. To find the common denominator, you're going to multiply this one by tangent, and you're going to multiply this one by tangent x. So in this case, tangent times tangent is going to be 6 tangent square to the x. Divide by tangent to the x. Hence minus 2 over tangent x equals 0. Now I have the same denominator, so I can combine these together. So it will be 6 tangent square to the x minus 2 over tangent to the x. Now let's look here. First of all, from the top, I can factor out the 2. So here's 2. And the left is going to be tangent square to the x, 3. Let's factor out the 2 as a common between these two terms. The left is a 3 tangent square minus 1 and divided by tangent x equal to 0. Okay, finish until now. Let's keep going on this example. So now after we factor out the 2, we have 3 tangent square x minus 1 over tangent x. I'm going to take 2 over tangent x, 2 over tangent x, and the left here is a 3 tangent square to the x minus 1 is going to be equal to 0. 2 over tangent is going to be 2, keep the 2 out. 1 over tangent is the cotangent. That means it's going to be 2 cotangent x, and here 3 tangent square to the x minus 1. We're going to use the 0 factor property. So give it 2 cotangent x equal 0. That means divide both sides by 2. So cotangent x is going to be equal to 0. So this is the first part. We need to find the angles, which is give you the cotangent equal 0, which is when you divide the cosine of this angle by the sine of this angle, the result should be equal 0. This is the first part. Now the next one, we need to solve this one. So 3 tangent square to the x minus 1 equals 0. Then move the 1, it's going to be 3 tangent square to the x equal 1. Then divide both sides by 3. So tangent square x is going to be 1 over 3. Then, take the square root for both sides, that's mean tangent to the x is going to be equal tangent to the x is going to be equal plus or minus 1 over square root of the 3. That's mean when you divide the sine of x of this angle by the cosine of x of this angle, the result should be plus or minus 1 over square root of the 3. I'm going to check that by going back to the circle to find the solutions for these angles. Finding the angles. So let's back to the circle, and we know the cotangent equals 0. That's mean cosine over sine should be equal to 0. So cosine divided by the sine should be equal to 0. And let's check the angles. Cosine divided by sine. Always, this is the cosine, this is the sine. So 1 divided by 0 undefined. So here is the first angle, because if I divide 0 by 1, cosine divided by 1 is going to be cosine divided by sine, it's going to be 0. Because always with the circle, this one as an x, y, cosine to the x, and sine to the x. So cosine, sine, cosine, sine, cosine, sine, on the whole thing here with the circle. And that's what we're gonna do here. We need to find cosine divided by sine equals 0. So now the next angle, if I divide -1 by 0 undefined. 0 divided by -1 is going to be 0. That means this is the second angle. So now we have two angles. We have x equal pi over 2 and x equal 3 pi over 2. Now let's check the next part. Tangent x equal plus or minus 1 over square root of the 3. That means sine divided by cosine. Sine divided by cosine should be 1 over square root of the 3. Let's check that. If I divide sine by cosine, yes. If you divide it, show you, sine is 1/2, divided by cosine, square root of the 3 divided by 2. Cancel the 2 with the 2, the result is 1 over square root of the 3. That's mean the first angle here is going to be pi over 6. So we have pi over 6. Let's keep going. Which other angle? Pi over 6. If you divide sine by cosine, it's not. If you divide sine by cosine, is not. Sine by cosine, here's the next angle. If you divide sine by cosine is going to be negative square root. So this is the second angle because we have the positive and negative. So it's going to be 5 pi over 6. If you divide sine by cosine here, sine by cosine, yes, it's going to be positive. So the next angle is going to be 7 pi over 6. Let's keep going here. Sine by cosine is not. If you divide sine by cosine is not, here's the next angle. If you divide -1/2 by square root of 3, so the other angles is going to be pi over 6, and it's going to be 5 pi over 6, and it's going to be 7 pi over 6, and it's going to be 11 pi over 6. 1, 2, 3, 4, 5, 6. 6 solution for this example. Example 7, we need to use the double angle formula. Think about that. The double angle formula, which is, we have a formula, it says sine 2u is going to be 2 sine u cosine u. I need to get back this part. I have sine cosine, I have sine x cosine x, but there is no 2. I have 3. So in this case, what I'm going to do, if you said here, if I multiply 3 is the same thing as 3 times 1. And here is sine x cosine x. Now 1 say that I'm missing two. One, I can say it's a 3 times 2 divided by 2, because 2 divided by 2 is going to be 1. Here's sine x, cosine x. Let's check what we do next. Yes, I have 2 divided by 2. Now, it's the same thing. If I say the 3 over 1, I can say it's 3 over 2 times 2. I'm going to write down 2 over 1. Here's sine x. Here's cosine x. In this case, it's the same thing. It's 3 over 2 times 2 sine x cosine x. In this case, it's equal. It's equal to 3 over 2. The whole thing here is the formula. So 3 over 2 sine 2. That's it. This is the solution for this example. Let's check example 8. We need to use the given condition to find the exact value of sine 2u, cosine 2u, and tangent 2u. And we have sine u equal -3 over 5, and they're telling you u exists on the fourth coordinate. So keep in your mind, u exists here. That means sine tangent is negative, only the cosine is positive. So the cosine is positive. Only the cosine. So let's check how we're going to solve this one. The first thing we need to find sine 2u. The formula for double angles, it says sine 2u equal 2 sine u cosine u. This is the formula. Now, so what's 2? I have sine u, which is -3 over 5 times, but we don't have cosine u. So in this case, how are we going to find that? You have two methods to find that. The first way to find how much cosine u is to use the identities. One of the identity, it says, if you need to find, we need to find the cosine. So cosine squared to the u, 1 minus sine squared to the u. You can use this identity. Let's check how we're gonna find that. We need to find cosine squared to the u. So cosine squared to the u is going to be equal to 1 minus sine squared, which is -3 over 5. -3 over 5 squared. That means this one is going to be equal. Cosine squared to the u equal 1 minus -3 squared is going to be 9 over 25. Then in this case, you can say 1 over 1 and find the common denominator. That's we multiply by 25 and multiply here by 25. That's the cosine squared to the u is going to be equal 25 minus 9 over 25, which is equal 16 over 25. So in this case, cosine squared to the u equal 16 over 24. Take the square root for both sides. So cosine u is going to be 4 over 25. Sorry, 4 over 5. And in fact, when you take in the square root, it should be plus or minus 4 over 25. Sorry, 4 over 5. It should be plus or minus. But I know the angle is in the fourth coordinate. The fourth coordinate, the cosine is positive, so I'm going to take the positive. That means it's positive. In this case, we have the sine, and we have cosine to the u equal 4 over 5. So you can do these steps before you start finding the first part, which is sine to u, because you need the sine and you need the cosine to find the sine, the cosine, sine to u, cosine to u, and the tangent also. So this is the first way to find the cosine. Let's check the second way to find the cosine. The second way to find the cosine, I know the angle is in the fourth coordinate. Let's check that. The second method to find that, I know it's in the fourth coordinate, so it's going to be here. And I know the given is sine to the u equal negative 3/5. So let's graph negative 3, which is sine is going to be the opposite of the angle over the hypotenuse. So we have these two information. So if you said this is the angle, that means negative 3 is the opposite. So here is negative 3. And the hypotenuse is 5, and we need to find the edges. So if you consider this is the u, this is the angle. This is the opposite hypotenuse, and here's the x. So in this case, we have right triangle, we're going to use the Pythagorean theorem. The Pythagorean theorem, it says the hypotenuse square equal x square plus y square. So square equal the opposite square plus the adjacent square. In this case, it's going to be 5 square equal the opposite is negative 3 square plus x square. So it's going to be 25 equal negative, maybe 9 plus x squared. Move the 9 to the other side by minus 9 from both sides. So x squared is going to be 16. So x, take the square root of both sides. So x is going to be 4. And again, it's a plus or minus. But if you look to the x here on this side, is the positive. So we take a positive. So now we find the adjacent. The cosine to the u is going to be adjacent over hypotenuse. The adjacent is 4. We get exactly the same thing. So now you have two ways to find the missing trig functions: using the sign, using the identity, or do exactly the same thing what I did here by using the Pythagorean theorem. So now we're going to find sine 2u, which is equal to sine u, which is negative 3/5, and the cosine is 4/5. That will be negative 12 times 2. The result is going to be negative 24 divided by 25. That's it for this example. Next one, we need to find cosine 2u, and again, it's up to you which, because with the cosine double angle, you will have 3 formulas. So to find cosine 2u, this is not 24. You can use 2 cosine square to the u minus 1. You can use this formula, which is equal to 2 cosine square, which is 4/5 square minus 1. That means going to be 2 times square first, then multiply by 2. 16/25 minus 1. 2 times 16, because this is over 1, 2 times 16 is going to be 32/25 minus 1. Then I can write down 1/1. And then you can multiply by 25 to get the common denominator. That's mean it's going to be 32 minus 25. So it's going to be 32 minus 25/25. It's equal to 7/25. That's it for the second one. And the same thing with the tangent. With the tangent you have, you can use the formula. With the tangent, you can use the formula for the double angle, or you can say, okay, tangent equals sine over cosine. I have the sine, I have the cosine. So you have two options. You can use the formula, or you can use the tangent is sine 2u divided by cosine 2u sine 2u. How much you get? Negative 24 divided by 25. Negative 24 divided by 25. And cosine 2u is 7 divided by 25. Cancel the 25. So the result is going to be negative 24 divided by 7. That's it for the simple example. For example 9. Need to find sine to the power 4 to the 2x. How are we going to do that? It's exactly the same thing what we did from the sine 4 to the x. Now sine 2x, you can say that it's sine square to the 2x times sine square to the 2x. Now, how are we going to use the formula? The power formula, but be careful, we have the angle is 2x. So the formula here for this part is going to be into here. Is going to be 1 minus cosine 2u. That's mean 2 times the u is 2x, so it will be 4x. And divide by 2. So that's the only difference. And multiply by exactly the same thing. So 1 minus cosine 4x and divide by 2. You do exactly the same thing that we did on the previous example. When we have sine to the power 4 to the x. 2 times 2 is going to be 4. That's going to be 1 over 4. And the left here is 1 minus cosine 4x. And multiplied by 1 minus cosine 4x. And then you can distribute. So it's going to be 1, 4. 1 times 1, 1 minus cosine 4x minus cosine 4x plus cosine square to the 4x. And then combine the like terms, so it's going to be 1 over 4, 1 minus 2 cosine 4x plus cosine square to the 4x. And now we have to use the whole formula again on this part. Okay. So it's going to be equal 1 over 4, 1 over 4, and here is 1 minus 2 cosine 4x plus here is going to be 1 minus cosine 2 times the angle, so it's going to be 8x and divide by 2. And we're going to do exactly the same thing what we did on the previous one. We're going to multiply 2 here, multiply by 2. Take this 2 with the 4, so it's going to be 1 over 8. 1 over 8. And then distribute this 2 here. But before we multiply, here it's going to be 2. So it's going to be 2 times 4 is going to be 8. And here's 2 times 2 is going to be 2 minus 4 cosine 4x and a plus 2 times the whole thing here, cancel the 2. So it's going to be 1 minus cosine 8x. Combine the like terms, so it's going to be 1 over 8. 2 plus 1 is going to be 3 minus 4 cosine 4x minus cosine 8x. That's it. Well, this example. Next example, number 10. We need to use the product to sum formula. The product to sum formula, first of all, you have to know the formula, which is half cosine u minus v minus, so the formula, if it's sine, so it's half cosine u minus v minus cosine, here's a plus and here's minus, u minus v. So this is the formula, and that's what we need to use. U minus v, no, the first one is u minus v. This one is minus, this one is a plus. When we have sine, this is minus and this is plus. So here's the formula. I'm just going to use the formula but first of all, locate, this is the u and this is the v. So to use the formula, it's going to be this one equal half cosine u minus v, which is 5 theta minus 3 theta, minus cosine u plus v is going to be 5 theta plus 3 theta. That means is going to be half cosine 3 theta, sorry, 2 theta minus cosine 8 theta. That's it. We compare the product to difference between two big functions. For example, 11, we don't want to use the half angle formulas to determine the exact value of sine, cosine, and tangent. But here's the angle, pi over 8. If you look to the circle of angles, you can't find angle pi over 8. But we need to use the half angle formula. And they're telling you which one you're going to use, half angle formula. So how are we going to do that? Half angle formula, it says u over 2. U over 2, if I look here to the angle, it's pi over 8. And let's do it here on the side. I can say pi over 8 is the same thing, pi over 4 divided by 2. Because if you say pi over 4 times, I can write down this over 1, and flip it, division to multiplication, that's going to be 1 over 2. And the result is going to be pi over 8, which is the same thing here. So I can write down pi over 4 divided by 2. That means the sine pi over 8 is the same thing, sine pi over 4 divided by 2. So here is the u. In this case, I can use the formula, which is square root of 1 minus cosine u divided by 2. The formula for the sine u over 2 is equal to square root of 1 minus cosine u divided by 2. This is the formula. U here, pi over 4. So it's going to be square root of 1 minus cosine pi over 4. Cosine pi over 4 and everything divided by 2. You just need to simplify it. So it's going to be square root of 1 minus cosine pi over 4, which is square root of 2 divided by 2 and over 2. So the next step, we just need to simplify. How are we going to simplify this one? You can say, okay, this is over 1, and you're going to multiply by 2. You're going to multiply by 2 to get the common denominator. So here's going to be square root of 2 minus square root of 2 over 2 and everything divided by 2. Because it's the common denominator. And in this case, it's going to be square root of 2 minus square root of 2 divided by 2 times, I can say this is over 1 times 1 over 2. In this case, it's going to be square root of 2 minus square root of 2 divided by 4. You can take the 4 out of the root. So it's going to be 2 minus square root of 2 divided by 2. So this is for the sine pi over 8. You can do the same thing with the cosine. Now cosine pi over 8, you can say the only difference is going to use the formula. I can say cosine pi over 8 is equal to cosine pi over 4 divided by 2, which is equal, this is the value of u, going to be square root of 1 plus cosine pi over 4 divided by 2. And this one is going to be equal square root of 1 plus square root of 2 divided by 2, and everything divided by 2. So it's the same steps here, the only difference here is going to be plus. Let's keep going. You can say this is over 1, and you're going to multiply by 2 to get the common denominator. So the next step is going to be square root of 2 plus square root of 2 divided by 2, and everything divided by 2. And it's going to be the same thing, square root of 2 plus square root of 2 divided by 4, and then you're going to take the 4 outside the root, so it's going to be 2 plus square root of 2, and everything divided by 2. So this is for the cosine pi over 8. For number 13, we need to use the product to sum formula. So it's a product to the sum formula. So be careful here on this one. You're going to use the formula only on this part. Do not do anything with the 3. So here is the 3 out, and the formula, this is the u, and this is the v. So it's going to be half sine u plus v. So the formula is going to be half sine u, which is negative a beta, plus v, which is 2 beta. Sine, this is the first part. And the second part is going to be minus sine, so minus sine u, which is negative 8 beta, minus v, which is 2 beta. Now we need to simplify it. So this part is going to be 3 over 2. Now here is going to be sine negative 8 plus 2 is going to be negative 6 beta, minus sine negative 8 minus 2 is going to be negative 10 beta. And we need to simplify it more. We already know that for the negative angles, if it's sine negative u equal negative sine u. When we have negative angles, only the sign is going to be negative. That's mean 3 over 2 sine 6b is going to be negative sine 6b minus sine negative 10b is going to be negative sine 10b. So that's b is going to be 3 over 2. Negative times negative is going to be positive. So it'll be negative sine 6b plus sine 10b. That's it. Or you can write down like this, or you're going to switch these two terms. It's going to be also right. Now you can write down 3 over 2 sine 10b minus sine 6b. Both is going to be right. That's it. Well, that's it. So the next example, we need to use the sum to product formula. sum to product formula. The first thing we're going to do, because you have two on both sides, on both these two terms. So the first thing, factor out the two. Factor out the two and use the formula. So I'm going to factor out this two from both sides, from both terms. So here's the two. And now the left here is going to be sine 3 theta plus sine theta. Now to use the sum to product formula, don't worry about this two. Here's open parentheses. There is another two with the formula. I'm going to use the formula only on this part. It's going to be 2 and it's going to be sine. You're going to say u plus v divided by 2. And cosine u minus v divided by 2. So it's going to be the formula u, this is the u, and this is the v. So it's going to be u plus v, which is the theta, divided by 2. Now times cosine is going to be u as a formula minus v divided by 2. In this case, 2 times 2 is going to be 4, and here's sine 4 theta divided by 2, cosine 2 theta divided by 2. And then it's going to be 4 sine 2 theta cosine theta. We convert the sum to a product and check the angles is going to be totally different. 2 theta, 3 theta, here 2 theta. Here's theta. So we convert from sum to product between the three fractions. You do the same thing for this example, use the sum to product. So we need to convert to product. Cosine 4x plus cosine 2x is going to be the same thing. Let's take cosine cosine. So in this case, this one is going to be equal as a formula 2 with the formula, and it's going to be cosine u plus v. This is the u and this is the v. So it's going to be 4x plus 2x divided by 2 times also cosine 4x minus 2x divided by 2. That's just using the formula, and then it's going to be cosine, here's 2, cosine 6x divided by 2, okay, cosine 2x divided by 2. And then this one's going to be equal to cosine 3x, here's cosine x. That's it. That's it. Moving to the next example. Let's see how we're going to solve this one. It's telling you find the exact value of sine theta over 2. Theta over 2, that means half angles formula, which is the formula. Says sine theta over 2 is going to be square root of 1 minus cosine theta divided by 2. You look, here's the theta, have the opposite, and have the edges, but there's no hypothesis. That's mean in this case, we don't have the cosine theta. We don't define cosine theta. So we're going to use the Pythagorean theorem. Let's say this is x. That's mean x squared equal 6 squared plus 8 squared. That's mean x squared is going to be equal 36 plus 64. That's the x squared equal under take the square root of both sides, so x is going to equal 10. That's mean x equal 10. In this case, cosine the theta equal 8 divided by 10. You can simplify it. 8 divided by 10, which is going to be 4 divided by 2. So that means cosine theta is going to be 4 divided by 5. So I can use this one as an angle and a plug in here. So in this case, sine theta divided by 2 is going to be 1 minus cosine theta is going to be 4 divided by 5 and everything divided by 2. So that's mean this is over 1. I'm going to multiply by 5, multiply by 5. So it's going to be square root of 5 minus 4 divided by 5 and everything divided by 2, which is equal to square root of 5 divided by 4 is 5 minus 4. It's going to be 1 over 5 and everything divided by 2. And this one equal square root of, I can write down 2 over 1. So it's going to be 1 over 5 times 1 over 2. And it's going to be square root of 1 over 10, which is equal to 1 over square root of 10. Sit or sit up. Simple 18. We need to find the tangent the whole 4 to the 2x. So let's check how we're going to solve this one. Now the formula using tangent to the power 4, it's tangent square to the 2x times tangent square of 2x. In this case, this one going to be equal. Tangent formula is 1 minus cosine 2u. If this one is u, I have to multiply it by 2. So 1 minus cosine is going to be 4x over 1 plus cosine 4x. And everything, you're going to do it again. 1 minus cosine 4x over 1 plus cosine 4x. Let's multiply here. Foil this one, it's like fraction times a fraction. This one times this one, this one times this one. But we have to foil. 1 times 1 going to be 1 minus cosine 4x minus cosine 4x and plus cosine squared to the 4x. Everything divided by. Everything divided by exactly the same thing. Plus, okay. 1 times 1, so it will be 1 plus cosine 4x plus cosine 4x plus cosine squared to the 4x. Now, next step, combine the like terms. So this one is going to be equal 1 minus 2 cosine 4x plus cosine squared to the 4x. Divide by 1 plus 2 cosine 4x plus cosine squared to the 4x. And then I'm going to go back and use the formula only on this part because it's squared. So I use the power formula on this part, which is going to be the formula for the square. This is 2u, 1 plus cosine 2u, that's mean 2 times 4x divided by 2. So it's going to be 1 plus 8. That's mean here is going to be 1 minus 2 cosine 4x plus, I'm using the power formula here, which is 1 plus cosine 2u, 2 times 4x is going to be 8x. Divide by 2. And everything divide by 1 plus 2 cosine 4x plus 1 plus cosine 8x divide by 2. Now we're gonna do exactly the same thing what we did on the previous examples. When we have sine and then we did cosine, we're gonna multiply here by 2 and by 2, and here also by 2 and here by 2. That's mean, or you can multiply only by 2 on the top and 2 on the bottom. You don't have to multiply and divide. That's mean cancel this 2 with this one and multiply the 2 here because for the whole thing here. So it's gonna be 2 times 1 is going to be 2 minus 4 cosine 4x plus 1 plus cosine 8x and divide by 2 plus 4 cosine 4x plus 1 plus cosine 8x. Combine the like terms, so 2 plus 1 is going to be 3 minus 4 cosine 4x plus cosine 8x divide by 2 plus 1 is going to be 3 plus 4 cosine 4x plus cosine 8x. That's it for this example.